This video is the extension of my previous video of empirical formula, molecular formula, in which I have covered the definition, some of the important concepts and formulas. So if you haven't watched that already, I'd encourage you to watch that first, since most of the part in this video will be dependent on that. In this video, we'll learn how to find empirical formula and molecular formula when percentage composition of a compound and molecular formula of the compound is given to us. So let us begin with the first example. The first example says an organic compound contains 54.5% of carbon, 9.1% of hydrogen, and rest is oxygen. Now, some of the very important points that we can note down from this data is this organic compound, which we are supposed to find, is made entirely of carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. While the percentage composition of carbon and hydrogen is given to us, oxygen needs to be calculated. The percentage composition of carbon is 54.5%. Hydrogen is 9.1%. Now we know that this is out of percent, that is out of 100, and the only element that remains is oxygen. So you have to consider out of 100 and subtract the amount of carbon and amount of hydrogen to get the final amount of oxygen. So 100 minus 54.5 minus 9.1. We get 36.4. So the percentage composition of oxygen is 36.4%. Now, since this is in percentage, we can consider 100 grams of a compound. Then 54.5 grams of that compound will be carbon, 9.1 grams will be hydrogen, and 36.4 grams will be oxygen. So let us just write that down. Carbon, hydrogen, and oxygen. So 54.5 grams is carbon, 9.1 gram is hydrogen, and 36.4 gram is oxygen. The next step is find the number of moles of each element. To do that, we're simply supposed to divide the amount of the element by its atomic mass. So the amount of carbon is 54.5 grams divided by its atomic mass, that is 12. For hydrogen, atomic mass is 1, and for oxygen, atomic mass is 16. Now if you're wondering why do we need to divide to find number of moles, it's a simple math. Let me quickly show you here. Now let us take the same example of 54.5 grams of carbon. So we know that in 12 grams of carbon, we have 1 mole of atoms. That is, in 12 grams of carbon, we have 6.022 into 10 raised to 23 atoms. So instead of writing it in that way, we simply write 1 mole. So we know that in 12 grams, that is its atomic mass, we have 1 mole. So in 54.5 grams, how many moles do we have? So when we cross multiply, we get 54.5 divided by 12. So by looking at this, we can generalize the idea. If you have X grams of an element in the compound, just divide it by its atomic mass. We had 54.5 grams of carbon. We divided it by its atomic mass, that is 12. We had 9.1 grams of hydrogen. We divided it by its atomic mass, that is 1. And we had 36.4 grams of oxygen. We divided it by its atomic mass, that is 16. So let us proceed further. So once we have this, we gotta simplify it. So 54.5 divided by 12. That will be 4.5417. Let me just round it off, which is equal to, for hydrogen it is going to be 9.1, and for oxygen, let us calculate again, 36.4 divided by 16. We get 2.275. 2.275. Now the next step is kind of important. In this step, when we get the number of moles, now these values represent number of moles of each element. There are 4.541 moles of carbon, 9.1 moles of hydrogen, and 2.275 moles of oxygen. Once we have these values, this step we gotta remember very carefully. You're supposed to divide these values by the smallest among these. So clearly, oxygen is having the smallest value with 2.275. So divide everything by 2.275. For hydrogen also, 9.1 divided by 2.275. And for carbon 2, 4.5417 divided by 2.275. So for carbon, it is going to be 4.5417 divided by 2.275, which is equals to 1.996. So we can approximately write it as 2. For hydrogen, it is 9.1 divided by 2.275. It is 4. Perfect 4. And for oxygen, this is going to mutually cancel each other out to give us 1. So these values that we just got, these represent the subscripts of the empirical formula. So now we have got the empirical formula. The empirical formula of the compound is C2H4O1. So the next step we are going to do, as we had done in the previous video, once we have the empirical formula, we're going to calculate the empirical mass of the compound. So empirical mass is equals to, there are 2 atoms of carbon and atomic mass of each carbon is 12. There are 4 atoms of hydrogen and atomic mass is 1. There's 1 atom of oxygen and atomic mass of oxygen is 16. 2 to 12 will be 24 plus 4 plus 16. When we add them all together, we get 44. Now we know the empirical mass, and they have given the molecular mass in the question. So molecular mass is equals to 88. So just like we had done in the previous video, we're going to first calculate the multiple constant N, which is equals to molecular mass divided by empirical mass, which is equals to molecular mass is 88 and empirical mass is 44. So when we simplify it further, we get the result as 2. So multiply this multiple constant to the subscripts of the empirical formula to get the final molecular formula. So this was the empirical formula. The final molecular formula will be equal to C2. So 2 will be 4, C4, H8 and O2. This is the final molecular formula that we are supposed to calculate. Let us take another example. The question is, a compound contains 69.9% of iron and rest is oxygen. Find the empirical formula. So in this problem, we are supposed to find only the empirical formula. Given the data as the compound contains only iron and oxygen. So it's an oxide of iron. So it's given that iron is 69.9% and rest is oxygen. So we can say that oxygen will be 100 minus 69.9. So when we solve it, we get 100 minus 69.9 is equals to 30.1%. So again, we'll follow the same steps. So the iron and oxygen, we are going to make 2 columns for iron and oxygen. Fe is the elemental formula for iron. Iron is 69.9% and oxygen is 30.1%. So if we consider 100 grams of the compound, then we will be having 69.9 grams of iron and 30.1 grams of oxygen. We're supposed to find how many moles of iron and oxygen are present. So we simply divide by the atomic mass. So the atomic mass of iron is 56 and the atomic mass of oxygen is 16. Most of the time, if there are high elements such as iron, the atomic mass will be usually given. So we don't have to worry about that. So when we simplify it further, we get 69.9 divided by 56. That is equals to 1.248. Now for oxygen, it is 30.1 divided by 16. That is equals to 1.881. Now we know that there are 1.248 moles of iron and 1.881 moles of oxygen. This is approximately. So now the second step that we need to remember here is divide both of these values by the smallest. So the smallest among these two is clearly 1.248. So divide both of them by 1.248. If there are 3 elements, you divide all 3 elements by that same amount. When we simplify this, this will reduce to 1. And for oxygen, it will be 1.881 divided by 1.248, which is equals to 1.50. So it is almost equals to 1.5. So unlike in the previous example, here we got 1.5, which we actually cannot round off because it is equally distant from 1 and 2. So what we know here is iron is present in the ratio of 1 and oxygen is present in the ratio of 1.5. So to make this a whole number, we multiply by a number which makes it whole. So if you multiply 1.5 by 2, it makes it whole. It should be also a smallest number, which will make it a whole number. So when we multiply it, we get iron is 2 and oxygen is 3. They are present in the ratio of 2:3. So the final empirical formula is Fe2O3. Iron is the subscript of iron is 2 and the subscript of oxygen is 3. Since they have not asked to find molecular formula and also not given the molecular mass, we need not have to find that. So let us take another example. A compound contains 57.80% of carbon and 3.60% of hydrogen, and rest is oxygen. We're supposed to find empirical formula and molecular formula when molecular mass is 166. So let's begin with the analysis of the question. It is given that carbon is 57.8%, hydrogen is 3.6%, and the rest is oxygen. So we are supposed to calculate it. How we do is 100 minus amount of carbon, that is 57.8%, minus amount of hydrogen, that is 3.6%. That will give us 100 minus 57.8 minus 3.6, which is equals to 38.6% of carbon. Now again, let us consider 100 grams of the compound. Since its percentage, there will be 57.8 grams of carbon. Let me write it down. There will be 57.8 grams of carbon. There will be 3.6 grams of hydrogen and 38.6 grams of oxygen. We are supposed to find the number of moles of each element. So just divide the amount of the element by its atomic mass. So it's going to be 57.8 divided by 12, 3.6 divided by 1, and 38.6 divided by 16. 12 is the atomic mass of carbon, 1 is the atomic mass of hydrogen, and 16 that of oxygen. So when we simplify this, we get, for carbon it is 57.8 divided by 12, which is equal to 4.817. So we write that down, which is equal to 4.817. For hydrogen it will remain the same, so we simply write it 3.6, and for oxygen it is going to be 38.6 divided by 16, so 2.412. Now this tells us that there is approximately 4.817 moles of carbon, 3.6 moles of hydrogen, and 2.418 moles of oxygen. So next step is divide each value by the smallest. Clearly oxygen has the smallest, so we divide by 2.418. So if we divide this, we get 4.817 divided by 2.412, which is equals to 1.997, which is approximately equal to 2. So we write approximately equal to 2. For hydrogen it is 3.6 divided by 2.412, which is equals to 1.5. So it's approximately equal to 1.5. For oxygen it is 2.412 divided by 2.412, so it's going to be 1. So carbon, hydrogen, and oxygen are present in the ratio of 1.5:1. Now we know that 1.5 is equidistant from 1 as well as 2, so we can't actually round this off. We multiply this by a number which gives us a whole number. So the number that we can multiply here is 2, because 2 into 1.5 will give us 3. So we multiply this by 2, and what we get is 4:3:2. So these represent the subscripts of each element in the compound. 4 represents carbon, and 3 represents hydrogen, and 2 represents oxygen. So C4H3O2 is the empirical formula of the compound. So now to find the molecular formula, we're going to follow the steps that I had shown in the previous video. First, we find the empirical mass of the compound. Empirical mass of C4H3O2 is, there are 4 atoms of carbon and atomic mass of carbon is 12. There are 3 atoms of hydrogen and atomic mass of hydrogen is 1. And there are 2 atoms of oxygen and atomic mass of oxygen is 16. So it is 4 into 12, that is 48, plus 3 plus 2 into 16 is 32, which is equals to 83. So it is given to us that the molecular mass of the compound is 166. So we directly know the value of molecular mass, so we just input that. Molecular mass is equals to 166. So now the last step in the process is finding the multiplicative constant. So for that multiplicative constant n, the formula is molecular mass divided by empirical mass. Molecular mass is 166 and empirical mass is 83. When we divide this, we get 166 divided by 83. It is 2. So the multiplicative constant is 2. We multiply this constant to the subscripts of the elements in the empirical formula to get a molecular formula. So the molecular formula of the given compound is C8, 4 2s are 8, H6, 3 2s are 6, and O4, 2 2s are 4. This is the final molecular formula of the given compound.